Εξαιρετικά. Μπορούμε να προχωρήσουμε λοιπόν στον Μάρο Πουλίζεβιτς από την Knauf Insulation. Είναι ερευνητής, ο οποίος θα μας μιλήσει για την ηχομόνωση στις εξωτερικές προσώψεις των κτηρίων. Έναν κανόνα πλέον και για όλα τα νέα κτίρια στην Ελλάδα. Νέα υλικά καλύπτουν τις παραδοσιακές ανάγκες μόνωσης, μόνο που ορισμένα από αυτά παρουσιάζουν και μια καλύτερη συμπεριφορά και ως προς τον ήχο. Maro, it's great to have you here with us today.
Thank you. Thank you for the invitation. It's great to be with you.
The stage is yours. You can start with your speech.
Thank you. Thanks a lot. As you said, my name is Maro Pulijizevic, and I am leading the research and development efforts in the field of acoustics for knauf insulation. So for those of you who are more familiar with knauf, which is providing complete building construction solutions, knauf insulation is more focused on the insulation side of the business. This illustration of the location of our plants might give you a good idea about our business and the magnitude of our business. So you can see we operate worldwide. We have plenty of mineral wool plants. And when I say mineral wool, some of them are rock mineral wool, some of them are glass mineral wool technologies. We have few in Europe producing wood wool, very popular product with architects, and few processing plants where our colleagues are pretty much cutting insulation to any possible shape according to project requirements. In total, Knauf Insulation has more than 6,000 employees, and we fit in the Knauf group, of course, which has many more employees. As an acoustician, when I joined Knauf Insulation, to be honest, the first comment from a lot of people was, you know, a lot of times we had the mineral wool in our hands. And we don't think it's anything so, let's say, spectacular. And I had to agree with my colleagues because indeed, when you take a mineral wool in the hand, a classical mineral wool, it does not look spectacular. And you would think it is just a classical product which you put inside the walls, inside the ceilings, usually with the good thermal properties, but for acoustics, it is as good as any other product. But usually I manage to change their minds when I show them the microscopic image of mineral wool. So this is the image of our mineral wool under the microscope, magnified, and just to give you an illustration about the size, the fiber size, so the diameter of fibers here, it's around 3 to 4 microns. So now when you see this, well, you can start to imagine that sound and noise will have problems to pass through this complicated network of fibers and pores. And me, together with a lot of colleagues, a lot of them being chemists, as we talked about chemistry, are working on the optimization of our mineral wool products. And some of the key factors which define the acoustic properties of mineral wool are fiber size, the orientation, are the fibers more horizontally oriented, vertically, or a bit randomly, as we see in the photo, the density of the entire insulation package, and of course, chemical composition. There are many other properties, but for the acoustic purposes, usually these are the ones defining the properties. And as today's topic is facades and sound insulation of facades, one of the questions we will try to answer in this presentation is, does insulation at all helps to increase the sound insulation? And which performance of insulation is at the heart of this performance? And that will give you kind of an idea of the efforts we are doing on a daily basis, how to optimize this performance. So once used in the project, it can perform as expected. But before we jump to that, I will just take a small step backwards and give you like a high level overview of various components which in the end create acoustically pleasant spaces. There is no straightforward way to explain this. There is no classical Wikipedia definition. This is something I came up with, but generally in one or another variation accepted amongst the acousticians worldwide. And for you here, I broke it down to 8 key components. So regardless of the building type, do we talk about residential units, hotels, hospitals, industrial facilities, nightclubs, restaurants, kindergartens, if we manage to take care of all these 8 parameters, we can be assured that our project will be acoustically successful. So the first one is something people are usually familiar with when we talk about acoustics. It's classical sound insulation between 2 interior spaces. The second one is sound insulation from outdoor noise sources, and that is something we are going to talk about today. Third one would be low noise from building services. So in modern buildings, especially in high energy performing buildings of today, there are many building services: heat, ventilation, air conditioning units, plumbing, elevators. You can just imagine what happens in the wall cavities and ceiling cavities in our buildings. Then it's not enough that we take care of the noise inside the building. It's very important that we do not pollute the environment with the noise. So we have to take care that our buildings and all the associated services, generally it's the services installed on the roofs level, do not emit high levels of noise to the environment. The fifth one would be related to vibration levels. So we do not want that our building vibrates from some indoor sources that can be, let's say, a very large air conditioning unit installed above the ceiling, or some outdoor sources, metro, train, industrial units. Then we come to the interior acoustics, and first we talk about interior acoustic quality, basically no acoustic defects. Classically, people can correlate this with no echo in the space, but there is a second level of this when we deep dive into it in a bit more detail, and with the careful acoustic treatment of our areas, we can increase the understanding, we call it intelligibility of speech, we can increase the quality of music in some very special projects. And in the end, something I really like as a topic, especially when talking to the architects, because architects indeed inspire me a lot in my work, is how to use acoustics as a design feature. What do I mean by this? I mean that you, as the architect, as a designer, engineer, you can choose how will your space sound. So it should not be a random outcome of various components. It should be your choice. So do I want my restaurant to be a bit more echoic and live? Do I want it to be a bit more quiet and private? How do I want my entrance of the hotel lobby to sound, and so on? So all these 8 are very powerful features. And it would be my pleasure if you have this screenshot somewhere next to your working desks and you consider it in your ideation process. And definitely we could make a nice workshop and meeting event about all of these 8 features. But today, let's focus on sound insulation from outdoor noise sources. So where do we start? Here's the quick checklist. So how to minimize the impact of outdoor noise. First thing, it's very important, maybe the most important, is when we start to work on the project, we need to understand the acoustic, I call it, footprint of project location. To do that, it's mandatory to perform noise level monitoring. Usually we talk about long-term monitoring, which means over the course of maybe several days, including working days and weekends. Why to do this? So when you do this, not only you understand the level of noise, but you identify main noise sources. So you know where is the main road, maybe, where is the railway, is there airport in the vicinity, any industrial facility, a restaurant which maybe gets very noisy at night, some particular heat, ventilation, air conditioning units of the neighboring building, and so on. I emphasize this especially in the modern world where we collaborate with the people on international level more and more. And I have personally worked as a consultant on many projects where main architectural team actually never physically visited the site. And they actually provided the design without being on the site. And when you do this, when we talk about acoustics, you can lose a lot of value. Why we lose a lot of value? Because we omit this third point. So once you understand the acoustic footprint of location, what happens on my location during the day, what happens during the night, how noisy it is, then already in the early design stages, you can locate noise sensitive areas away from noise sources. So noise sensitive areas will be bedrooms, living room, definitely classrooms if you are designing a school, hotel rooms, and so on. So it would be a big mistake to locate your majority of bedrooms facing the main road or main railway. Of course, if we have the luxury to change that and play with the location during the design process. Sometimes we do have, sometimes we don't. But just by smartly orienting our rooms in relation to the noise sources, we can easily reduce sound inside the building, even by 10 dBs, just to these, we call them shielding effects. Next component is the thing that we are going to talk about today, where insulation plays a big part. It's actually the selection and design of building envelope elements. So I'm not only talking about the solid parts of the facade, wall together with insulation system, I'm talking also about all the possible elements which are part of this system. So all the transparent elements, windows, doors, any kind of ventilation openings, and so on. And in the end, one thing that we usually forget, and at the end of the presentation, I will show you one very nice example, when we don't consider the integrity of building envelope. So building envelope is one system. So if your facade in the end is going to be as strong as the weakest link of your building envelope. So if we forget about small details such as ventilation openings, air inlets or outlets, we can seriously reduce performance of our facade, regardless of the quality of our main wall, of insulating elements, and so on. But again, let's focus on insulation part of the presentation, and let me tell you something more about selection and design of building envelope elements. So which are those key parameters which will in the end determine the sound insulation of our outside wall, which pretty much presents the first level of defense between our interior acoustic comfort and the crazy and noisy world which is surrounding us today. So first we start with the base wall. So base wall can be anything today, made of concrete, masonry, timber, depends on the project, location of where you're building it. There is a wide variety of base walls. And sound insulation of these walls will again vary depending on their type and the thickness. For example, 100 millimeter cross-laminated timber, so timber construction, is around 34 dBs. Typical block wall of 250 millimeters, it's something around 40 to 50. It will, of course, depend on the block type. So now the insulation layer can actually increase this, but definitely you can imagine we can make more increase on the constructions which are by themselves lower performing. So increase on timber construction will be of a much larger magnitude than the increase of the block wall or concrete, which is by itself already very decent insulator. Now we move a bit away, next step from the base wall, and we talk about insulation. So very important parameter is the thickness and density of the insulating layer. Here, very intuitively, the thicker, the denser insulation will be better. There are some ifs and buts. I will tell you about it at the end of the slide. Next very important parameter is thickness and weight of the render. So your final coating of the facade will play a role in the final sound insulation level of the facade that we achieve. But the most important parameter when we talk about insulation, the parameter which is at the heart of our research and development process, imagine those fine fibers at the beginning of the presentation, is the stiffness of the insulating layer. So the most important characteristics. And the lower the stiffness, the better it is for the facade. So to translate this into different words, the more elastic or fluffy the insulation, the better the acoustic performance. Now I come back to those ifs and buts. So there is a fine combination of optimum performance of density. So we still want our material to be dense, but we do not want it to be too rigid. Why? Because of certain, let's call it resonance effects, which happen if you select wrong insulation. So wrong selection of the insulating layer, selecting too rigid layer can do something very unexpectedly. I mean, people usually do not expect this, but yes, it can happen. So wrong selection of insulating layer can actually reduce the acoustic performance of the base wall. So in the best intention to protect the building, to insulate it, to provide thermal performance, acoustic performance, we can actually do wrong and even reduce the acoustic performance. It does not sound so easy or straightforward, but here is an illustration why does it happen. I'm showing the research of several universities which actually focused on performance of mineral wool of contact facades, so-called ETIC systems. In their case, they used a block wall filled with the concrete, which by itself achieves 59 decibels. If you are not familiar with the acoustic graphs and charts, don't worry, they are not complicated at all. So on the vertical axis, which have a value of sound insulation, on horizontal axis, the frequency range. And this RW, we can call it like a generally average figure if we average all these frequencies. Now, what happens when we add, for example, mineral wool wall? So insulation, sorry. So mineral wool insulation added to the main wall, in this case, increased the performance across all the frequency range. And in the end, this resulted in 11 dBs improvement of overall sound insulation. On the other hand, this project focused on rigid insulation as well. Remember, we said stiffness, rigidity, elasticity, the most important parameter. Here is what happens with, in this case, EPS, which is more rigid than mineral wool. If you ever had in your hand polystyrene and mineral wool, this is kind of a straightforward effect. So by using a very rigid insulation, here is where the resonance effect happens. So in the lower frequency, you can see the insulation is reduced. Not something that is self-evident, but it actually happens. And due to this reduction of sound insulation, our average sound insulation figure was reduced by 3 dBs. So this is a straightforward example how, I would say, non-convenient selection of acoustic insulation sometimes can lead to reduction of insulation of the main wall, which sometimes can result in the problems in real projects. And here, to come back to the story, how much insulation can we improve with mineral wool facade insulation? So in this case, we talk about 11 dBs. We talked about block wall, but let me show you how powerful it can be when applied to timber constructions. As we said, magnitude of improvement is larger for walls which are lighter and, let's call it, lower acoustically performing. So this will be the result of an actual test undertaken not so far ago in Italy on a classical, very popular these days, cross-laminated timber of 100 mm. So on the outdoor side, there was a 100 millimeter knauf insulation mineral wool applied with a typical 5 millimeter render. And on the inner side, so towards the internal spaces, again, additional 40 millimeter insulation in this installation gap with 2 boards of gypsum. So what happened? These are the results. So base wall, if you remember from previous slides, of 100 millimeters is close to 34 dBs. Once insulation layers are applied, it's a staggering improvement of 28 dBs. So these two slides, these two examples show you that good selection of insulating, let's call it coating of our building, can indeed improve sound performance of our facade and can improve the acoustic comfort. Of course, let's not forget about the story of integrity of the facade and the importance that windows will have. So any system will have to be considered as a whole, and the selection of windows will have to follow and go hand by hand with the selection of insulating system. But again, very interesting, don't forget, if we choose too rigid insulation, we might reduce the expected sound insulation of the wall. And in the end, I promised to you one very interesting example, a case study, what can happen if we neglect importance of this so-called integrity of building envelope. Here you can see 2 photos from Slovenia. So I'm actually based in Slovenia. Our research center is located here, of a very simple family house which underwent energy renovation recently. On the left side is before photo, on the right side photo after the renovation, so almost 100% completed. If you can spot some differences on the roof, you can see that solar panels have been added, some units of HVAC. On the right side, next to the entrance, there is a heat pump, and the entire facade is sparkling in a new color. Actually, it was coated with insulation, very thick insulation, acoustically highly performing, thermally highly performing, and it gave a nice aesthetic appearance too. And to everyone's surprise, we received one day a call that the tenants of this building, after the completion, they were very excited because their building is now energy efficient, their quality of life should be better. They were complaining that traffic noise seems to be more audible to them. You can see the setting of the building is a bit rural, so we talk about a village, but still there is a kind of a regional road passing in front of their bedrooms, and they experienced more problems with the noise after the renovation, and it was mind-blowing because it was not supposed to happen. And then we went to the field, to the site, to see what's actually happening there. And here are some photos before, after of the main facade. And if you look very carefully, there are three very interesting elements on this after photo. So I have encircled them here in red, and those are actually ventilation openings for the heat exchangers. So in very modern buildings, which are thermally very efficient, usually very airtight, you need to have some air exchange. And typically there are various heat exchangers which can enable that. But all of them terminate at the facade. And there are many solutions available on the market. Some of them acoustically rated, some of them not acoustically rated. But generally, all these devices are nothing more than openings in the facade. They can be covered with a certain protective mesh, but at the end, it is a whole, it is a small downgrade of our facade. And once we did some acoustic tests, so on the photo, you can see on the left side, the loudspeaker, the omnidirectional loudspeaker placed on the floor, the microphone very close to facade, and next to this person conducting the test, and my colleague, you can see something very weird, which we placed in one of these openings. So we did the test with the opening, and then we put, well, we had with us some towels and blankets, and we did our best to, let's say, fill the opening and to prevent sound leakage, because indeed, when you enter the room, you could hear a clear sound leakage through the facade, through this opening. And once we did this, we discovered that because of the opening, because of the heat exchanger, there was a 10 dB, which is huge loss in the acoustic performance of facade sound insulation. So again, very good example, a first-hand experience how in the best possible intention that you have, if you don't pay attention to all the small details of the facade design, you can quickly ruin the acoustic performance of your facade. And for the end, to keep everything on time, again, something that you can take as a screenshot as the main takeaway message, these checklists, these 5 most important steps for you to consider when you will be designing your project and the building envelope next time. So first, understand what's happening on the project location, where are the noisy sides, what are the noise sources, identify those main noise sources, and accordingly, try your best to locate noise-sensitive areas away from them. By doing that, you will avoid a lot of unnecessary cost, and you will avoid a lot of complaints of future tenants. Then, when you come to the point of selection and designing building envelope elements, take big care of all the elements, so glazed parts, openable parts, solid parts, and insulating layer. Remember the story, it should not be too rigid. There is a fine balance of density and rigidity. And please do consider the integrity of building envelope. This is something I usually suggest to architects to sit down with mechanical engineers, because usually there are a lot of mechanical services which find their way somehow to the end of the envelope. And in the end, sometimes if we don't pay attention, they penetrate the envelope and make things worse despite the best possible insulation you might use. And that was it from my side for today. Thank you very much. Thanks, everyone.
Thank you, Maro, and we were just in time. We do have a couple of questions, but time is running, so we'll get back to this answered in archisearch.gr. It was insightful indeed, and we proceed directly.